Hello everyone. On this occasion today, we are from Group 7 in Inorganic Chemistry course. Will show you our PDO lab report about coordination of D block element. And our experiment is about transition element of metals ion. Now, I'm going to introduce our group members. There are Anissa Nur Fitriani, Indria Rahmawati, and Fairuzahwa Patimah Nurdini. Hope you enjoy this video. And here are the materials and equipment we need to do the experiment. For the material, there are copper 2 sulfate with 0.2 molar, iron 2 sulfate with 0.2 molar, cobalt 2 chloride with 0.5 molar, natrium hydroxide 1 molar, ammonium hydroxide 1 molar, and distilled water. For the equipment, we need test tube and also the test tube rack, pipette, and some labels. The objective of this experiment is to investigate how different transition metal ions like copper 2+, cobalt 2+, and iron 2+ respond to ligand addition by observing the color changes and formation of precipitates when reacted with ammonium hydroxide and sodium hydroxide. Now, we are entering on how we prepare the solution to get the concentration needed. First, we need to balance all the compound based on the result we got from the calculation. After balancing all the compounds, put it on beaker glass, pour a little of distilled water and stir until it dissolves. When it already dissolved completely, pour it into the volumetric flask by using funnel, and after that add the remaining water needed. Lastly, we need to shake the volumetric flask for at least 20 times, and then the solution is ready to use. Do the same for the other compounds, including the ammonium hydroxide, but because it's liquid, we use the different formula to get the amount we needed. After all the solutions are ready to use, we can pour copper 2 sulfate, iron 2 sulfate, and cobalt 2 chloride to the test tube. And since we compare the result from natrium hydroxide and ammonium hydroxide, so we need its solutions into test tube. And here is what's happening when sodium hydroxide and ammonium hydroxide is dropped to the solutions, and the result will be explained later.
So this is the result of our experiment. The initial color of ClCl2 is red solution, CuSO4 is blue solution, and FaSO4 is clearly yellow solution. And then, after the experiment, ClCl2 reacts with sodium hydroxide and ammonium hydroxide produce a blue precipitate. CuSO4 reacts with sodium hydroxide and ammonium hydroxide produce blue precipitate. And last, FaSO4 reacts with sodium hydroxide and ammonium hydroxide produce a grayish green precipitate.
Alright, so here is our discussion for this experiment. The first is about the reaction with sodium hydroxide. When sodium hydroxide was added to the metal salt solution, hydroxide ions react with the metal ions to form insoluble metal hydroxide. As you can see in the pictures, copper 2 produces a blue precipitate of copper 2 hydroxide, cobalt 2 formed a blue-green precipitate, and iron 2 formed a greenish-gray precipitate. These results are consistent with the expected behavior of transition metals, where the pretty faulty orbitals give rise to characteristic colors. Okay, next, the reaction with ammonium hydroxide. A similar pattern was observed when ammonium hydroxide was added. Initially, the same colored precipitate appeared, blue for the copper, blue for the cobalt, and green for the iron. This occurs because ammonium hydroxide exists in equilibrium in water and releases hydroxide ions. As a result, the metal ions first react with hydroxide ions, forming metal hydroxide precipitate, just like in the sodium hydroxide reaction. Since the coordinating ligand is the same hydroxide, so the observed colors are also similar.
An additional observation was made in the iron sample. The greenish precipitate gradually turned brown on the surface. This change is due to oxidation, where iron 2 hydroxide reacts with oxygen from the air to form iron 3 hydroxide, which has a brown color. This behavior highlights the redox activity of iron and its tendency to change oxidation state. Overall, the experiment demonstrates that transition metal ions form characteristic hydroxide precipitates when react with basic ligands. The similarities between the sodium hydroxide and ammonium hydroxide reaction show that hydroxide ions dominate the initial coordination, while the color change and oxidation behavior confirm the key properties of transition metal related to d orbital and variable oxidation state. That's all for our video. Thank you for watching.